Welcome back to another episode of Solidity Fridays. I'm joined today by William Schwab, Rory Simmons, and for the first time, Tamara Ringas. Tamara, welcome. Tamara is a Solidity developer at Linum Labs. Do you want to tell us about yourself, Tamara?
Yeah, sure. Firstly, thank you so much for having me on the show. I love the show. Yeah, I'm a Solidity developer at Linum Labs, and I've recently also gotten quite into Cairo. Yeah, I'm very interested in security and zero-knowledge proofs. And obviously Uniswap v3.
Awesome. Yeah, and as you say, today we will be going through Uniswap v3. And you wanted to go through a specific Solidity version, right?
Yes, so in May, they released a 0.8 branch, which was very cool. I was recently doing a project in Foundry, and we were using 0.8.12, and then most of Uniswap v3 was in 0.7.6. So we ran into some problems with the deploy script. It's not as easy as hard hat to deploy multiple versions, but we eventually figured it out. But then I realized that they had just released a 0.8 branch, so I'm very excited about that.
Awesome stuff. Yeah. So, I mean, I have up here the introduction post, the blog post of Uniswap v3, and this was about a year and a half ago. But before we get into this, do you want to take us through like a brief history of Uniswap?
Yeah, cool. So version 1 was just an AMM that allowed traders to trade with pools. And every pool had to have Ethereum in it. So let's say if I wanted to swap USDC for DAI, I had to interact with the USDC ETH pool and then the DAI ETH pool. So it was 2 pool interactions, which they then remedied or like improved with version 2, where pools didn't need ETH. And then it became like the most popular app on Ethereum, and I think one of the most forked projects. Yeah, and then in March 2021, they released V3, which its main thing was it allowed for concentrated liquidity. So instead of your liquidity being spread across all like price values, you can choose which price value you want to position your liquidity on, which multiplies capital. And yeah, they also changed the liquidity pools are NFTs, I think, NFT based instead of token based.
Right. Yeah, I guess we can like go through this blog post just to recap some of those key features that you just said. But yeah, as far as I'm aware, the big changes from V2 to V3 were the concentrated liquidity. So where you have the power to sort of specify a price range within your pair that you're allocating your liquidity to. And then when it slips out of that price range, your liquidity doesn't really serve as liquidity for a swap. And then with that comes the sort of side effect that LP positions, so liquidity provider positions, are no longer fungible, or they're no longer interchangeable. So in V2, all liquidity providers were providing across the entire range on that like X times Y equals K curve. So that would make that allowed the LP tokens to be ERC20, so these fungible tokens, which was quite nice for DeFi, for that allowed us like another sort of like a fungible token in the DeFi ecosystem where you could lock those tokens somewhere or stake them to farm or to get rewards. But then along came Uniswap v3, and with this nice feature of concentrated liquidity, those LP positions were no longer fungible. So now they're represented by NFTs, by ERC721 tokens that specify exactly where your liquidity is provided in the range on the curve. Yeah. Is there anything you want to add there, Tamara?
I don't think so.
I think that's, yeah, I mean, that's like kind of, I love the graphics that Uniswap made for this announcement. I think this is like, it's so illustrative of like what's actually going on in this when you're adding
Oh,
liquidity.
cool. I've never seen this.
Yeah, this is a really cool post and like a pretty exciting announcement in DeFi when it came out. I remember they were very secretive about it and started like teasing Uniswap V3 for a while, and we were like, oh, what are they going to launch? And then this came out. Yeah, capital efficiency. I think that they said something like you can get up to like 4,000 times as capital efficient. Yeah, relative to V2 because you can concentrate it so heavily. Yeah, so like on those, like where that might apply is on stablecoin to stablecoin pools. So with like DAI and USDC, you could LP one of those pairs, and the expectation is that they should basically always trade 1-to-1. And so you can concentrate your liquidity on like $1.0001 to 0.999 in that sort of like very, very concentrated like price range or exchange rate range. And then that's really where you get the 4,000x capital efficiency. But yeah, very cool graphics. And I noticed they had at the time it was like really cool that this had like a Trail of Bits audit, an ABDK audit. They had Samsung audited as well, but no reports, sadly.
Yeah, it's really cool that the Trail of Bits audited them. They're my favorite auditors.
Yeah, they're great. All right, so are you ready to get into the code?
Yeah, awesome. Let's do it.
Sweet. So here we are in the repo. I think I jumped ahead a little bit here, but here's V3 call.
And then maybe instead of being on the main branch, let's go to 0.8.
Right. I think I have, yeah, on these files open, they are in 0.8.
Oh, okay, cool. Sorry.
But yeah, I guess just to see if there's anything interesting on the README. William, anything you notice?
Not off the top of my head. I mean, there is the echidna file, which we were talking about beforehand. But nothing's popped out to me.
Yeah, interesting.
Oh, they're using Yarn version 2, it looks like. That's an interesting choice.
Oh, nice. Yeah. This will, so if we go to the 0.8 branch. And of course, this was back in 2021 in March. So Hard Hat was still the de facto environment to build these things in. I don't think Foundry was even like out at all at that point.
Yeah.
December of that year.
Yeah.
Oh wait, no, I can't tell time anymore. December of some year, either 2020 or 2021. I think 2021 actually.
2021, surely. Yeah.
I think so.
Yeah, it's gotta be.
Yeah. Sweet. All right, well, let's get in. So we have the contract, and there's not too much going on here.
Yeah.
We've got the factory, the pool, and a pool deployer.
Yeah, so the factory deploys Uniswap V3 pools and manages ownership and control over pool protocol fees.
Okay, cool. So where should we go first?
Let's start at the factory, but it probably imports a bunch of stuff that would be interesting to look at as well. There's some really interesting libraries in this contract.
Cool. Oh, and I remember, Will, you mentioned there's a good libEVM post, which we could pull up as well.
I think it would primarily be good just to see if we end up doing like the life cycle of the swap or something like that. I think there has been some confusion in V3 vis-a-vis V2 about like how to interact, like how to interface. So I think if anything, it'll probably help with the entry point, not necessarily like the whole life cycle in the contracts, but just to know like where things start, they get put in. I am assuming that that would be like, the best use for like this particular blog post. Big shout out to LibDVM for it.
Yeah, I think Lib's parting it up in Paris right now. Sweet. So this is the libvm post. Swaps. Right. So this is how you would go about doing a swap in Solidity. Tamara, do you want to take us through this, or do you want to go straight into the code? What do you want to do here?
No, I'm happy to take us through this.
Okay.
So yeah, once you've set up a pool and interface with the factory and everything, once you get to the swap, use the ISwap router from the periphery contract, not the core, which is deployed at that address. And then you get two types of swaps, an exact input swap and an exact output swap. My understanding is that an exact input swap, you say like, I want to spend this amount of WETH, and I'll get the maximum amounts of DAI for that. Whereas exact output, you say, I want exactly this amount of DAI, and then they'll tell you what amount of WETH to put in. So yeah,
Nice.
you use the router, and then you put an exact input swap with the parameters. And where are those params defined?
So I remember, I'm not sure exactly where. They'll probably be in an interface, I assume.
Oh, it's in periphery, not in core.
Right. Yeah. I think you're right. Let's go to periphery. So it's here, but it's probably in the interface of the router, right?
Yeah.
ISwap router. There we go. So these structs contain all the data for a swap of like a different type. So exact output params, these are the params you need to specify for an exact output swap. All
Okay,
right.
cool.
Cool. And then quotes. Okay, so this is just to get like the price quote.
Yeah, it's a spot price.
Yeah.
They have something else called TWAP, which is time-weighted average price, which I think is better than just getting a spot price. And you can specify the duration you want to get a time-weighted average over.
Yeah, I guess it depends what you're. If it depends, I suppose, what you're trying to do. Like if you just actually are trying to swap, then.
Oh yeah, I guess you want the price at that exact moment.
Yeah.
Yeah, fair enough.
Do you know? I'm not sure about this, but like, I assume when you're doing a spot price and getting a quote this way, you can specify the size of the swap, right? So, where is our iSwap router? We need to go to the quote thing, hey?
Yeah, iQuota.
iQuoter v2. Yeah, so amount in this would like give you here you could specify the size. Now, can you do the same thing in the TWAP article, or is it just sort of a spot price of like 1 unit for a TWAP oracle?
I think, yeah, I think it's for 1 unit.
Yeah, I mean that makes sense to me. So the TWAP oracle, I guess, then doesn't have any sort of like measurement of like liquidity depth, which makes sense because like that's like another whole parameter that you would or another dimension over time. So I mean, then you have price over time, but then you'd also need to have liquidity over time.
Yeah.
So it's quite a lot of data you're now playing with.
Yeah, so I just checked the parameters for get square root TWAP is the address of the pool and then the TWAP interval, which is a UN32.
Cool. All right, should we go back here? Yeah, so then that just gets you like your quote, but then in this spot price function, you'd be able to specify the size, which then takes into account, I guess, liquidity and slippage.
Yeah, which I think is the one E18 in this case.
Yes, yeah. So you would have this is a like token in, right? So you're
Yes.
swapping with for synthetics. And shout out to synthetics, by the way, they've been doing super well recently. And that's another one I would love to cover at some point when they do their V3.
Oh yeah, that would be cool.
Yeah.
And then that 0 per am is the square root price limit, which is basically like the slippage amount.
Yeah, so that's you specify I guess like a price limit, and if it goes beyond that price, then you don't want to do the swap anymore.
Mm.
So this is like also your MEV protection in a way. Like if you're getting sandwiched, you can limit the slippage.
Yeah, which is nice. I wonder if they had that in V2, probably, but yeah.
Yeah,
they
they
did V2 also.
Yeah, they did. Sweet. Adding liquidity. I mean, like, I don't know how much of this. I guess we could just quickly look at adding liquidity and then jump across.
So yeah, you'll add non-fungible liquidity.
Yes.
And I think that non-fungible position manager is in periphery, not in core. So it's interesting. Core, most of the stuff you interact with is in periphery, not in the core contracts.
I mean, that it kind of makes sense, right? Because you probably like core is I mean, its responsibility is that it should be like the most efficient, like logic, the most gas efficient logic for your protocol, which it is. Well, it's efficient like logic for the protocol. Like you have your factory, which just creates pairs, and then your pools. That doesn't necessarily imply that it's like very user friendly. So I think then it somewhat makes sense to have a set of contracts like on the periphery that are then designed to be like user friendly contracts for interacting with that core protocol. Like you could then build in your functions that have like meta transactions, like permit for to save users gas, so they can do transactions just by signing a message, and that sort of thing. And then you could also delegate or like do user swaps through the router, which may be a lot more user friendly and efficient, capital efficient, than if users were to sort of like manually specify the swap route through like various pairs or pools.
Yeah, that makes a lot of sense.
Yeah. Sweet. Should we jump into this GitHub?
Yeah, cool. Maybe we look at the V3 factory in 0.8. Yeah, we're on the 0.8
Okay,
branch.
cool. That's here.
Do you want to start with the interface or the contract?
I guess we could take a quick look at the interface. Here we go. All right, so, well, that's interesting that it's a 0.8 Solidity branch, but the interface is, just greater than 0.5.
Very interesting. And then they have some that are strictly like 0.8.13 and 15, and then some that are 0.8.12, and then some that are greater than or equal 0.7.6. So I wonder what the reason is for all the different ones.
I guess you don't have to update this. Like this will be compatible with the 0.8.12, which is here. And then for the rest of the repo, but yeah, I'm not exactly sure. Anything else you find interesting here in this interface? Yeah, it doesn't look like too.
Yeah, it's too dense.
Yeah, there's no structs defined here. Just some events, the owner change and the pool created, and then your usual functions sort of defined here.
Yeah.
All right,
And
I guess
great
let's jump
comments.
in. Yeah. Okay, Tamara, wanna take us through this?
Yeah, okay, cool.
I guess.
So firstly, what is BUSL 1.1? What is that license? Do you know? Like, what does it entail?
So this was like a big controversial thing when Uniswap v3 came out. Before then, I think Uniswap v2 was MIT licensed, I believe, or
I think so.
GPL, but it was open source basically. And then with v3, they created this business license. So Will has jokes. He says it's bustled for real, no cap. Thank you, Will. So they they created this business license. So the idea when Uniswap v3 launched at the time, I think the big story was SushiSwap. That was one of the big stories in DeFi at the time. And SushiSwap came along and forked Uniswap v2 and did the whole vampire attack in DeFi summer, and which basically facilitated a migration of liquidity from Uniswap v2 to SushiSwap. And SushiSwap added a few things at the time, like most notably, I suppose, is the Master Chef contracts for staking your LP tokens to sort of farm the sushi token. And the other thing was that with this new sushi token, they would take a little bit of the fees that the protocol generated and take them away from the liquidity providers and direct them to the token stakers, to the sushi token stakers. So then there was at the time there was this whole like tension between SushiSwap and Uniswap. And so when Uniswap released version 3, it came along with this business license, which was controversial because you didn't back then. You didn't really see these smart contracts, the Solidity code, and these protocols coming out with like permissioned licenses that you now need to get permission to copy. Otherwise, there are like maybe like legal ramifications.
Yeah, I can't blame them though.
Yeah, I mean, I think the idea with this one, if I recall, was that it's 2 years. I think it's probably specified here. I think it gave them 2 years. To the license holds that you can't copy it without permission, and then after 2 years or something, it expires. So then it is here we go.
Okay, that's cool.
The license, right?
Time delayed GPL. Okay, yeah, that's really nice. That's pretty clever, and yeah, fair enough.
Yeah.
Also, in 2 years, it'll probably be V4.
Yeah.
Cool. So
that is the license story.
So the Uniswap, so it imports a few things, and then it inherits the interface and a pool deployer and no delegate call. Interesting. That's also in core. I wonder why. We can look at that soon.
Which one? The no delegate call?
Why it uses the no delegate call contract, but we can look at that contract later maybe and see what it does.
I mean, okay, let's actually even take a look, just dive in, because it is a good question. I did notice it there at some point. No delegate call. Right, so as expected, it's like
to a contract.
Yeah. So what's original here addressed with this? So when the factory is created, basically this no delegate call little additional inherited logic stores the address of the contract uh, that the contract that has been created. In this case, it's the Uniswap v3 factory contract. So when you deploy that, it'll store that address as the original. And then it just, if a function has no delegate call modifier on it, it'll run this check not delegate call logic, which is here, which just says that the context or the address of the contract calling the function must be the same as that original contract's address. So it's effectively what it's saying is that if we find one of those functions somewhere, I don't see one. Interesting.
Yeah.
Maybe it's inherited in that. No, that wouldn't make sense.
No, because yeah.
Okay, yeah. So, but like, assume one of these functions had that logic. It would mean that you wouldn't be able to delegate call that function from another contract because it would execute that function in the context of that other contract. And at that point, this address.this would be the address of that contract, which would not equal the address of the original, which would be factory. So yeah, as advertised, it stops delegate calls.
I wonder why they would want to stop delegate calls.
Yeah, I mean, it may be. I wonder if they found some sort of vulnerability.
If there are details being written in order to tick the price, so they'd be written in the storage of the calling contract. I don't know if that's the reason, but it's the first thing I can think of.
Yeah, but it's, I mean, that doesn't really like break anything about the Uniswap v3 protocol, as far as I could tell. Like that might
price won't tick accurately, no?
Oh, right. So you're saying you could like execute a swap, but without
moving the price.
Yeah.
Oh, interesting.
I don't know if that's right though. That's just like a shot in the dark.
That's a good guess.
Yeah, that's a really
to me.
interesting attack vector.
Yeah. Sure, they're clever.
Wow. I wonder how they discovered that exploit. If they, I assume the process was that they just, built out that functionality, and then like one of the auditors or someone internally at Uniswap or Samsung pointed out that you could do that for the delegate call.
I think we're all imagining a Telegram message that reads you up, but yeah.
We have a message in the chat asking, why is the license identifier important for us to mention in our contracts? Is it a permission of some sort? Yes. So it says what your contract, it's like the licensing. So it's the permissions that people can, whether they can or can't reuse your code. So this is saying that you can only use it after 2 years.
Exactly.
Okay, cool. So we have the address of the owner, and then fee amount tick spacing mapping. I'm not too sure what that would be. Oh, I think it's because it's concentrated liquidity. Maybe that's like you can choose your where you put your liquidity in the factory. I don't actually know.
Fee amount tick spacing. And like you can see here, it's the mapping is from a uint 24 bits to an int 24 bits, which is interesting. Yeah, and I wonder, does this maybe specify the width or the size of a tick?
It says it returns the tick spacing for a given fee amount if enabled or 0 if not enabled.
Okay. Yeah, so you can see here in the constructor, it sets that up with the given basically the fee structures in Uniswap. You have like 3 different fee tiers, which is I think this is it 0.05%? this is 0.3%, which is the usual fee on that was around in Uniswap v2. And then this is 1%. So this is the largest fee. This is the usual fee from Uniswap v2, 0.3%, and this is a much smaller fee, so 0.05% on each swap, which I think the introduction of this fee tier was specifically for stable coin swaps or like assets that would trade in a very concentrated range, because Curve had a very low fee for that use case as well. So I think this is where they were trying to compete with Curve.
I see. And maybe that's where you get that 4,000 times because of the low.
Yeah. But like specifically for this mapping, it looks like that this number here sort of dictates the width of a given tick or liquidity range. I think that's what this is, right?
Yes,
tick is a liquidity range. So this is like the width of it. So in the smallest one, it would be like 10,
like almost like a fine point, and then in the bigger one, it's a range.
Yeah.
Okay, interesting. And then these events that it's emitting, those they got from the interface.
Yeah, exactly. But I wonder what this 10 means, or the 200. Does this mean sort of basis points in terms of a token, or is it like actual units?
It says that I don't know. It just says the tick spacing.
So like if you have a WETH to DAI pool, and that it says the normal 0.3 fee structure, what does 60 mean there? Is that like 60 way of WETH or 60 way of DAI, or is it like I assume maybe it would be 0.6% of one way of one WETH. I don't know. Yeah, so I'm not sure there.
Yeah, I'm also not sure. But you're right that the tick is the liquidity range. So
yeah.
So I think you could be right, but I can't say for sure.
Yeah, I'm not sure. Anyway, so that's just those fee structures are set up in the constructor of the factory. Want to keep going?
Yeah, cool. So create pool. Oh, here we go. It has a no delegate call.
Hey, missed that. Yep. So we can't. That's interesting though, because now our theory or Will's theory was that it would be on swaps, which I guess it might still apply, but this like create a
it might
pool.
also be there.
Yeah.
So why wouldn't you want to do a pool through delegate call?
I mean, it might still be that logic.
Writing the wrong thing to storage, the wrong storage rather, yeah.
Yeah.
Okay, yeah.
You just it like skips updating some sort of important storage in the protocol.
It probably wouldn't be registered in Uniswap, you know? Like, I don't think there's any loss of user funds involved with that. It's just the gas of calling it should be kind of utterly futile. It could be that there's some kind of vector that would let someone kind of, I don't know, I'd want to think about that more, like what you could do if like be registered in Uniswap, but would still be Uniswap compliant. I wonder if there's something there.
Yeah, it could be. Cool. So create pool, it takes two addresses, the two tokens, and the fee. I wonder why it's a UN24.
Where is this? The fee, UN24. So this is probably due to some struct packing going on somewhere.
Mm-hmm.
I assume maybe here in the deploy. Yeah. and deploy. Is that a function somewhere? No.
I think we'll get that from the Uniswap
prob-
v3 pool
yeah.
deployer. Yeah.
Yeah.
We could look at that maybe now. Or do you want to
Yeah.
finish looking at this function first?
So it looks, I mean, here, this is basically, yeah, let's, I mean, it would be interesting to just point out that if it is the, if it is some struct packing going on. There we go. Okay, no. Well, kind of. This is just the interface. Here's the pool deployer contract. There we go.
Yeah,
there's
a
our
struct.
actual
Nice.
struct. There we go. So what we have, so we've got each address is 20 bytes out of the 32 of a struct. So none of these would pack together because they each take up 20, so you can't pack two
they
together.
can't fit them in one, yeah.
Yeah. But for this last one, this UN24 will take up 24 bits, which is 3 bytes, and another 3 bytes here.
I see.
So that's 6 bytes, which you could pack in with this address. And that should take up 1 slot.
Very
but
cool.
it's still I mean, you have more space left over, so like theoretically these could have been larger variables, take up more memory, but I assume it's also just because they don't need so much. Like if it's out of if it's a fee over some sort of scaling factor like 100,000, you really don't need so many bits for that. But yeah, so that looks like that's what that is. Where were we? I did lose my place. That's the deployer.
Yeah, should we look a bit more at the deployer or? No, it's okay.
Here's the factory, sorry. Just got lost there, but.
So we're on create pool. Okay, yeah, so we first require that you aren't creating a pool with the same token. Fair enough. Okay, and then this is quite interesting. I think they're saying if the address of token 0 is greater than the address of token 1, swap them.
So yeah, we've seen this before in a previous episode. I think Will actually found an exploit in some protocol. Was it? Oh, I think it was
Helios. I don't think it's an exploit. I think with Helios there's an issue for pools who are using ETH.
Yeah.
It's patched.
Nice. So here, basically, what you want to do is you want to organize token 0 and token 1 such that they are alphabetically arranged. And that's what you're doing here. You're just comparing basically alphabetically or by casting those two addresses to like integers. You're saying, okay, token 0 and token 1 equals if token A is less than token B, so alphabetically it's higher up than token B, then we want it to be token A and token B. But if this doesn't hold, then token B is alphabetically higher up, so we want token B to be token 0, so we swap them around. And that's so this whole line just kind of sorts token 0 and token 1 alphabetically. And that's important because when you deploy, if you have a deterministic sort of arrangement of these two tokens, then I think everything else about each pool contract one that's deployed is deterministic. So you could before deploying the actual contract, you can deterministically guess the address that it will be deployed to. So that's quite nice for like UI or testing. You know, if you have like this given address for like width, this given address for die, and everything else is deterministic about that pool, then you can like beforehand calculate the address that pool will be deployed to. Yeah. And that obviously wouldn't hold if you can't if you just let token 0 and token 1 be kind of like whatever is input here.
Yeah, whatever's the user inputs, yeah.
Yeah.
Okay, cool, yeah. And then it requires that token 0 is an address 0. Cool. Oh, and then they get the tick spacing from that mapping.
Yes. So yeah, so they pull that out. And they're saying it mustn't be 0, which basically, I think this implies that it can only be one of these sort of specified fee tiers. Yeah, because you specify your fee here so that you want to create the pool with, and if it's not one of these fee tiers,
like 4,000 or something.
Yeah, then this will return 0, and then it will revert here, right?
Yeah. Okay. Cool. I'm surprised. Can you say like required equals this or this or this? I think you could.
Or you could do that, sure. So you could say
required one of those exact values.
Yeah, in this require, you could say fee equals exactly like 500 or 3,000 or 10,000. But I mean, you need to go through this step, I guess, either way. And also, this is more scalable. So if you had like 20 fee tiers, then you would be doing that across 20 things.
Yeah, nice.
And
you'd have to rewrite it.
Yeah, and you would, well, at the end of the day, you still have to like do this read for a given fee tier, get the actual tick spacing so that you can set up the pair. So you might as well do that here, save that in memory, and then do your checks on it.
Awesome. And then they use a function get pool, which I think is that further down maybe, or is it in the pool contract?
Get pool. Well, this looks like a mapping. Get pool. Yeah.
Oh, nice. Okay.
There we go. So I think we
address.
skipped over this actually, but yeah.
Yeah, we were so involved with the fee amount tick spacing that we moved on.
Should we take a quick look here?
Yeah, cool.
So, and like here in get pool, I remember we had something very similar in that Helios episode where we didn't exactly know what all of these parameters were in this mapping, and then it was like more apparent when you look at the code. So here in get pool, you can see that you put in the 2 addresses of your 2 tokens, so token 0, token 1, and then this uint 24 is your fee.
That would be the fee, yeah.
Yeah, and then that would return the address, an address here that your pool is deployed at. And so what this requires is checking that returns.
It's not addressed there.
Address,
okay, yeah, fair enough.
Which means that that pool or that pair has not been deployed yet. Because if it wasn't address 0, then there's something deployed there.
Yeah, then you can just access that pool instead.
Exactly.
That needs to create it again.
Yeah.
Okay, cool. In line 46, pool equals deploy, address this. I don't know where they get deploy. I think it's from the deployer again. Must be.
This was the deployer. Yeah.
You deploy it to this address. Interesting. And oh no, it's saying, wait, what is the first parameter? Is that the deploy to address, or is it in line 46? Yeah, address this. Is it saying deploy from address this or deploy to address this? Surely wouldn't be to.
No, not to. I mean, that's pointing to this factory, this factory contract.
Yeah. So
it's probably, it might be some sort of like ownership thing that says we have been deployed. This contract is deployed, but that also doesn't make too much. It because you could read that off with the message.sender, right? Oh, it's not. Yeah, message.sender. It might be something to do with like preventing Delegate calls.
Oh, it could be.
We already have that.
I think actually it has to do with, it could be because you could have multiple instances of factories. So it's saying that this is the factory deploying that pool.
Should we just go look at it? That would probably make sense, wouldn't it? To actually just look at the logic. It's as if we read code on the stream sometimes.
Sometimes.
Yeah, sometimes. There's deploy. Okay, so factory. Yes, so you specify your factory.
The factory, the contract address of the Uniswap
Yeah.
v3 factory. Okay.
I mean, but right. So it looks like you could have multiple factories, and then here, when you are calculating the address of your pool, so it doesn't even actually take into account the factory for that deterministic address, because you can see we're just hashing token 0, token 1, and the fee, the salt. Parameters,
maybe this just allows us that, like, ensures that only the factory can call deploy pool.
Yeah, I'm not really sure why. Okay, it doesn't. Parameters. So, that's weird. So we're creating this. Oh, okay. This is interesting. So there's this like global variable, this global single struct parameters. And maybe this is something to do with MEV or some exploit, because it looks like it can only do this once per block, right? Well, I don't like, this is where like you would definitely know more than me. But it looks like we're saving this, or I guess once per transaction. So we create one of these parameters structs by populating this data, which is factory, token 0, token 1, fee, tick spacing. And that gets saved globally in this deployer contract. And then we actually create the pool, we deploy the pool, and return that address. And then we immediately, at the end of that function call, we delete parameters. So I guess that zeroes out this single variable. It's
what were you saying about the once per block or 1 per TX though? Like, why would that restrict it to 1 per TX?
No, actually, I don't. I mean, it's, yeah, there's no restriction here, right? Because there's no required checking that this like is zeroed out. What it probably is now is that that I've just sort of like maybe noticed is that once you deploy the pool, maybe the pool reads something off of this parameter variable, this parameter object.
Makes sense.
Yeah. So it would be able to read this, and at deploy time, and then once that's happened, then it zeroes this out. So that's like, but it's
yeah, you'd still be left with the question of why though, like why to engineer it that way and not just pass it in as parameters or something.
Exactly. I'm not too sure.
Perhaps this weekend I'll read those audits and see if it was an exploit they found.
Yeah, be interesting. There's so many like slightly different things going on in Uniswap v3 that like are just like a little bit different to how you would just generally engineer contracts, in my opinion.
I've also felt that way. But I think it's as a result of like a lot of thinking and a lot of like engineering and ingenuity.
Yeah, I assume there's like they went with this idea of like concentrated liquidity, and then really like, you know, built that out as gas optimal as possible. And then that probably created a bunch of side effects, or yeah, and then this architecture maybe with the router and the various pools in the factories. And then once they had that, there were probably a few exploits or things, and they had to maybe just engineer around those a bit, like with this no delegate call.
Okay, cool. So we deploy the pool on line 46, and then we get the pool. Sorry, just we map it. We put it in the mapping.
Yeah.
Yeah, populate the mapping in the reverse direction. Okay, yeah. Deliberate choice to avoid the cost of comparing addresses.
Yeah. So then I guess if you're reading from this mapping, get pool, as we do here, where is it?
On line 45, yeah.
Yeah. Then you don't have to read this twice.
Very clever.
You would like, because you might check this one and then you swap those tokens around and check, okay, was it actually populated another one? This is probably quite an expensive read. Whereas yeah, so we could just, you know, store both of those and then only read once.
Clever. I like that a lot. Cool. And then you emit the event that was defined in the interface.
Yep. Nice.
Cool. Set owner. Is that just like standard. A owner? Yeah, that's cool. Pretty standard. Enable fee amount.
So I guess this is like, yeah, there's your only owner.
Okay, so and you put in a given tick spacing, and then it enables a fee amount.
And there we have our sort of max number in the tick spacing, which is 1 million. And this is probably why why the fee variable is only 24 bits. So if we go 2 to the 24 minus 1, I mean, it'll be, I think, a lot bigger than 1 million. Yeah. No, actually, not. I mean, yeah, you can take up to. Oh, but it's also an integer, right? So we would halve that number. So like, oh no.
Shout out to brackets.
Shout out to brackets. There we go. I mean, still, we've got a lot of space to play with. But yeah, you can see we're kind of at least within the same like order of magnitude by using 24 bits.
Interesting.
So I think we have like 5 minutes left. Do you want to quickly jump into, we didn't really get to the pool contract.
Yeah, let's look at the pool.
Okay. Anything you want to jump into here quickly?
Can we look at that struct slot 0?
Sure, go for it.
Cool. So square root price 96, current price, current tick. Observation index. Where is that observations array?
Observation index. The most, okay.
Oh, that's
this is for the TWAP, right?
I think it might be TWAP uses observe.
Yeah.
Okay, cool. And then sure.
There's oracle.observation. Observations.
Okay, so it's actually for the Oracle library, not the
but it's interesting they named the struct slot 0. I assume. There you go.
Yeah, that's very interesting.
I mean, it wouldn't in this contract, and maybe like correct me if I'm wrong, Will, it wouldn't actually be like slot 0 because this is like
it's not deployed first.
And here these are taking up other slots.
That's what I would have thought.
Unless wait, these are immutable. So are these not stored in the byte?
Immutables in bytecode, you're right.
Yeah, bytecode, right. So this is actually,
So it is actually slot 0.
yeah, slot 0. So this is the first slot in storage.
Yeah, good.
Hey.
Nice. Cool. Then they have the fee growth global and 0 and 1 times. I'm not sure what those are, to be honest. Let me pull up the docs.
Fee growth global 0x128. Interesting. No idea. Maybe these are indexes for keeping track of like fees accumulated in a pair for your LPs. It's interesting that.
I wonder if they're storing ints and uints.
Yeah, I mean they're defined as 2 full uints.
So it says here the fee growth 0x128 is
for the
as
token
a
0 maybe.
Q128.128 fees of token 0 collected per unit of liquidity for the entire life of the pool.
Okay, cool. Right, so Rory has to bounce, so I guess let's cap it here. Yeah, Tamara, this has been super interesting. Thanks for taking us through Uniswap v3, especially the Solidity 0.8 one for relevance.
Yeah, cool. Thank you for having me. I really enjoyed it. Yeah, I wish we could have gone through more. It's such an interesting set of contracts.
Yeah, and there's so much more to unpack here. Potentially, as we always say, we could do an episode 2 one day.
Yeah, I'd love that. Cool. Have a good Friday, everyone.